tell you I found a lot of error codes, and we're going to take a few moments, the next 30 minutes or so, we're going to review a set of data that I found that is generating this one error code. It's just creating all types of downtime. So I'm hoping that after I go through all this data with you, it comes in more than one part. We can, work together and find a solution to make sure that our company is very profitable, very efficient, and of course, a safe environment for all of our employees.
One eternity later.
Alright guys, so now that I've finished going over that data with you, I want to talk about the changes that we're going to implement to make sure that this error code isn't going to happen anymore. Yes.
How are we going to do it?
I'll show you.
2 hours later.
Alright guys, so now that we've taken the time to go through all this data and all these tables and kind of showed you what the changes are going to be, it's time to talk about how we can implement these changes safely, because safety is our utmost importance here at this plant.
For mechanical engineers involved with manufacturing, one way we use statistics is in the collection of tool data. In an automotive plant, there are hundreds of electric tools which track torque, angle, speed, and many other measurements when tightening a bolt on a car. These tools generate error codes which impact the productivity of the assembly line. It is the engineer's job to collect this data and evaluate it to determine which tools are creating the most downtime, and then develop a solution to eliminate that type of error.
Aerospace engineers use statistics in manufacturing in many ways. When it comes to designing aircraft, engineers use structural analysis to develop the fuselage or the wing. Statistics comes in handy during this process to know what types of materials works best for the certain applications. And we can analyze strength versus weight when it comes to the fuselage skin and use statistical analysis to figure out the most optimal combination for parts.
Using data on a day-to-day basis to carry out their jobs. We will face frequent upset conditions within a plant and be tasked with resolving the issues through the use of the data from the time when the conditions occurred. Examples can include determining causes to flow losses in piping systems or issues with product quality and then producing plants to correct the upset condition. Also, we will develop projects through the use of historical data that allows for predictions of potential project benefits for the plant. This may include using concentration and flow data of liquid streams to determine if recoveries of certain parts of the stream are worth doing for sale or use. The data from the predictions results will then have to be evaluated for monetary value and rates of returns to provide project justification before implementation. On a long-term scale, chemical engineers will provide overall process optimization to meet plant goals such as production capacity increases and decreases in production costs to maximize profit.
Creating more personalized education creates a safer environment in manufacturing. Any operator, engineer, or technician with a few years' experience statistically will have more problems with tasks as compared to veteran workers having a larger knowledge of the subject at hand. But when dealing with changes to a system, each technician, veteran, or new hire will need to be introduced to new techniques. This allows for an ever-changing environment in the workplace, optimizing the field of manufacturing.